Dear listener, welcome to my channel. Topic of this video is to find out two regression lines, that is y on x and x on y. Also find out the relationship between the slope and coefficient of correlation. In this video, concept, derivation and exercises are covered. Now let us start. Relationship between the slope and correlation coefficient. For bivariate data, the relationship could be y is dependent on x or x is dependent on y. If y is dependent on x, the regression line is called y on x and the dependent variable is y and the independent variable is x. If x is dependent on y, then regression line is x on y with x being the dependent variable and y being the independent variable. When x is known, the regression equation y on x is equal to y equal to p plus qx, where p is intercept and q is the slope, and it is used to estimate the value of y. When y is applied to the regression equation, that is x on y, x is equal to s plus ty, which is used to estimate the value of x. Here in these two equations, this p, s, q, t are the parameters in which p and s are slope while q and t are the p and s are the intercept while q and t are the slopes. Now we'll see what is meant by R. The correlation coefficient is a statistical descriptive measure of the strength of the linear relationship between the two variables. It has a value range of -1 to 1. A correlation coefficient of -1 denotes a perfect negative correlation in which value in one series rise while those in other fall, and vice versa. A coefficient of 1 indicates that there is a perfect positive correlation or a direct relationship, that is one series increases and the other series will also increase, or the vice versa. A correlation coefficient of 0 indicates that no linear relationship exists between the set of data. We can see the correlation using the scatter plot. Now here we can find out that data is positively correlated because this line has a positive slope and this line has a negative slope, and data is across this line, so it is a perfectly correlation and it is negative correlation. Here we can't find out any line through which all points will be going or close to that line. That's why the data is independent, that is no relation. Correlation of coefficient of x and y is the same, that is rxy is equal to ryx. We can find out the correlation by using the Pearson formula. So this is a Pearson formula by which we are calculating the correlation between the two set of data. Relationship between the slope and correlation coefficient. This is a relationship between the slope and correlation coefficient, that is beta 1 is equal to r into standard deviation of y divided by standard deviation of x. So this is the case. Here it is standard deviation of x and r is standard deviation of y, and beta 1, that is slope, is equal to this relation exists. And for intercept, average of y minus beta 1 into average of x. So this is the formula of to calculate the intercept. Now see the example. Here x and y points are given and the points are same. When the points are same, their average is same and standard deviation is also same. And when points are same, they are linear and perfectly linear relationship exists between them. So when we find out the correlation coefficient, that value comes as 1. And when we find out by using linear regression, we are getting the slope as 1 and the intercept as 0. So coefficient of correlation is 1, and while equation is y is equal to x. Now if we see this formula, here we calculated slope as 1, relationship coefficient of relation is 1, and the standard deviation of x and y is same. So left hand side is equal to right hand side. Now we will check the different types of data. Now this is the x and y. We will find out the average, then standard deviation. Then when we plot the data, we are getting like this. Now here when we apply the linear regression, we are getting the answer as r is equal to 0.9x plus 7.6, where 0.9 is a slope and 7.6 is an intercept. For this data set, when we calculate the correlation of coefficient, it is 0.74. Now if we apply this formula, that is beta 1 is equal to r into standard deviation of y divided by standard deviation of x. Now r is 0.74 into 8.38 divided by 6.89. 89, we will get the value 0.9, which is equal to slope. So this is very important derivation, that is, this is the relationship between the slope and the correlation of coefficient. Now for this, here it is y on x, that is x is independent variable while y is dependent variable. Now we will see the relationship. Now when we see the formula of beta 1, that is slope, it is covariance of xy divided by variance of x. This I have already covered in my previous video of linear regression, that is beta 1, that is slope, is equal to covariance of xy divided by variance of x, and the correlation of coefficient is covariance of xy divided by standard deviation of x into standard deviation of y. If we, as we know this relation, that is beta is equal to r into standard deviation of y into standard deviation of x. If we put the value of r, then we are getting this equation, and when we solve, we are getting the equation, that is beta is equal to covariance of xy divided by variance of x. Now this is for y on x, where y is dependent and x is independent. That is, we can establish the relationship between the covariance of xy, standard deviation of xy, variance of xy, and the correlation coefficient. So in exam, when question comes, they may give the value and we require to find out the, for example here they may provide the 3 values and we have to apply the formula to find out the remaining values. Now covariance of xy is equal to expected of xy minus expected of x into expected of y, and variance of x is equal to expected of x square minus expected of x square, and this is nothing but the formula for mean, that is expected x is equal to, this is nothing but the mu, beta is nothing but the covariance of xy divided by variance of x. So when we put this value, we are getting the answer like this. Now here when we apply, that is expected value of xy, which is nothing but summation of xy, and expected value of x is nothing but the average x, and expected value y is equal to average of y. So basically it is divided by 1 by n. So this is divided by 1 by n, and this is also divided by 1 by n. So when we divide again by numerator n, we are getting the answer n into summation of xy minus summation x summation y divided by n sigma x square minus sigma x whole bracket square. So this is the equation for beta y on x, where y is depend on x. Now this is the formula. Now we require to find out the 2 regression line. One is yx and second is xy. In xy, x is depend on y, means x is dependent variable where y is independent variable. So in this formula, on the numerator side will remain same, only the denominator will change with respect to independent variable. We can write down the slope equation in another form also, that is y minus y bar is equal to beta yx x minus x bar, and this is for y on x, and for x on y it is x minus x bar equal to beta xy into y minus y bar. Now again this is the standard equation, that is correlation of coefficient is equal to multiplication of beta xy into beta of yx. Now beta of yx is equal to r into standard deviation of y divided by standard deviation of x. This will true when y is dependent on x, but for when we calculate for bxy, it is r into standard deviation of x divided by standard deviation of y. So these formulas are very much important. Now we will solve the problem. Exercise 1, find 2 regression lines, that is x on y and y on x. This data is given. Now by seeing the formula, we require summation of x, we require summation of y, then we require summation of x square, summation of y square, then entire summation of x and their square. Now here we require 3 extra column, that is xy, x square and y square, and the average of x bar is equal to 6 and average of y bar is equal to 8. When we write down the slope intercept equation, then we are using this x bar and y bar. Now when we find out this, we require to just put the values. So from the table we are just putting the value, and this is the respective calculation. So we are putting that n, total 5 number of records, summation of xy, summation x, summation y, and all the remaining values. When we put the values, we are getting that beta of yx is equal to minus 0.65 and beta of xy is equal to minus 1.3. We can put into the equation. This is y minus y bar is equal to slope into x minus x bar, and after solving the equation we are getting y is equal to, because here y is on the left hand side because it is dependent variable and x is independent variable, where in bxy x is dependent on y, therefore x is equal to minus 1.3y plus 16.4. Exercise 2 is very much similar to the exercise 1, only the values change. So to solve this problem, we require to make the 3 new columns, make the calculation, and it is very important to remember the formula only for one side. The other side we can easily remember. Now we are just putting the value, and after that we are getting this slope, and we are putting that values into the equation. So in this way the problem can be easily solved. Now exercise 3, in which if we want that if the values are large, at that time we can use this dx and dy method. That is, we are not taking the original value, but we are taking the values in which we are lowering the precision. So it is very easy to calculate in the exam. There is no need of calculator. For example, now for x 1 to 7 values are there, so it is not hard and fast that we will choose the 4. We require to choose the value in such a way that which will represent the median, and here we are selected here 4, and out of this value we selected 11 here. Now we are not doing the operation on the xy, but we are doing the operation on dx and dy. So here a is 4, b is 11. For dx we require to subtract each value of the x and y by the a and b respectively. Here we are getting dx and dy. So 1 minus 4, 2 minus 4, 3 minus 4, 4 minus 4. In this way we are making the d of x, and from y we are subtracting the 11 and we are getting this. When we make the summation, we can find out that most of the time if data is symmetric in nature, we are getting the summation close to 0. So it is very easy for the calculation, and we are just putting the value and we are calculating the answer. So here we are getting the answer 0.93, 0.93, and we are putting the value into the equation. So all these calculations are similar to exercise 1 and 2. Now this is a similar problem to the exercise 3. Now here values are given and we choose 13 as a center. Even we can use the interval to divide this. For example, dx is equal to x minus a divided by h. Now here h is 1, but if we want to make, for example, sometimes if 10, 20, 30, 40, 50, 60 values are there, so all intervals are same, so we can divide the value by a particular interval. So 10 to 60 value will be represented, that is subtracted from the median, and after that it is divided by 10. So it becomes very much easy to do the calculation. So similar way is applied, only we require to deal with dx dy, and in this way we are solving the problem. So just we require to put the values and put into the slope intercept form equation. Now this is exercise 5 and I have solved partial problem, and the remaining problem you try at your end. Now for this 40 is taken as median and 45 taken as median. I didn't take that interval divided by h, but we can take that interval also. And after that dx dy, their multiplication dx square dy square, x bar and y bar we can calculate, and we require to find out byx and bxy. So we just require to put the values into this formula and we will get the answer. The coefficient of correlation between the two variables x and y is 0.48. The covariance is 36, variance of x is 16. Find the standard deviation of y. Here we require to check what is given in the problem as a input. R is equal to 0.48. Then covariance of xy is 36 and variance of x is 16. As we know the equation, that is R is equal to covariance of xy divided by standard deviation of x into standard deviation of y. So here all values are provided except the standard deviation of y, and we solve this equation and we can get the value as 18.75. So the problems are very much easy, only important is to remember the formula. Find the estimated value of x when y is equal to 12.2. So here from the problem we have to understand that find the estimated value of x when y is equal to 12.2 means we are predicting the value of, that is y is independent variable and x is dependent variable. We will get a particular equation and we are putting the value of y, and after that we will get the value for x. Now here mean of x, mean of y, standard deviation of x and standard deviation of y is given, and r is equal to 1. Now this formula, that is beta of xy, that is x is depend on y. The formula is r into standard deviation of x. Here we require to use standard deviation of x divided by standard deviation of y. We require to put the value. So here you people should not make the mistake that what has given and how to use this formula. So you have to remember when you are using the formula bxy or byx, and rest of the things are very much easy to do the calculation. So we are getting the value x equal to 17.99 when y is equal to 12.2. Now in the next problem, from the following data calculate the expected value of y when x is equal to 22. So average, standard deviation and correlation coefficient is given, and we require to find out the two values, that is byx, and even we can find out the bxy. X is equal to 22, expected value of y when x is equal to 22. So here y is independent, x is independent and y is dependent variable. So we require to calculate b of yx where y is depend on the x value. For the next problem it is given that we require to calculate byx as well as bxy, because find the value of y for x equal to 50. Here x is independent and y is dependent, and find the value of y for x is equal to 50. Here x is independent variable and y is dependent variable, and find the value of x for y equal to 30. Here y is independent and x is dependent. So here in this case we require to calculate byx and bxy. So only the important thing is to remember the formula and apply properly, and we will get the answer. So this is for bxy where y is independent and x is dependent variable. Next problem, find the mean values of variable x and y and the correlation coefficient from the following regression equation. Now the equation is given 2y minus x is equal to 50 and 3y minus 2x equal to 10. So these two equations are given. After solving the simultaneous equation we will get x is equal to 130 and y equal to 90. So it is very much easy to solve the simultaneous equation and we are getting the answer. Now here we require to find out y on x and x on y. Now first equation we take or we make the assumption it is on y on x, and the second equation we make the assumption on x on y. Now for the first equation 2y minus x is equal to 50. Here x is independent variable, so we have to write down the y is equal to, and here as y is independent and x is dependent, so x will come on the left hand side. So we require to arrange this equation, and when we arrange the equation in this format, here we can easily understand that 25 is intercept but 1/2 is slope, and which is beta of yx, and when we arrange this equation we can easily come to know that 3/2 is a slope and which is nothing but bxy. r is equal to square root of bxy into byx. When we put the value, we are getting the value as 0.866. So we can easily find out the correlation coefficient. Now last problem. Two random variables have the regression equation. This equation is given. Find the mean values and the coefficient of correlation between x and y. If the variance of x is equal to 25, find the standard deviation of y from the data given. So I have not solved the problem, but when we solve, first we require to solve this equation, and when we solve the simultaneously equation, we are getting the value of x and y, and they are actually representing the mean. Then we can easily find out the beta yx and beta xy, and from that we can easily find out the correlation coefficient, which is square root of byx into b of xy. And once we know all the values, we can put into this equation and find out the standard to find the standard deviation of y is easy. So that's all about the x on y and y on x, that is to find out the two regression lines and relationship between the covariance and correlation of coefficient, and the relationship between the slope and correlation coefficient. Thank you.